The amp, meter, and second are SI base units. State 2 are the SI base units. All right, so you need to remember that we have 7 base quantities, and these 7 base quantities, they include current, whose base unit is the amp. We also have distance, which has meters as its base unit. Another base quantity is time, which has its units as seconds. Then the other base units that we can talk about is the Kelvin, which is a base unit for temperature. We can also talk about mass being a base quantity and its base unit being the kilogram. The average drift speed v of electrons moving through a metal conductor is given by the equation v is equal to mu f over E, where E is the charge on an electron, F is a force acting on the electron, and mu is a constant. Determine the SI base units of mu. For us to determine the SI base units of mu, we need to make sure that our equation is homogeneous. What do we mean by the equation being homogeneous? The base units for either sides, left or right, should be equivalent. They should be the same if an equation is homogeneous. So by this principle of homogeneity, we are going to determine the base units, SI base units of mu. So we'll start by substituting the units for each of the quantities. So for V being speed is measured in meters per second. Substituted is equal to, for the constant mu that we are determining the base units for, I'm going to put my mu right there. Then, of course, for the rest, I'll keep substituting the SI base units. So we take a look at force. The SI base units for force, we should know that force is calculated as mass times acceleration. And SI units for mass, that's the kg. SI base units for acceleration, meters per second squared. So I substitute the SI base units for force. Now we take a look at the denominator, which is the electron charge. Charge is calculated as current times time. And the SI base units for current is the amp. SI base unit for time is seconds. So therefore, the base units for charge is the amp second. I substitute amp second. I'm going to evaluate the base units on the right hand side, and I'll see what values I should substitute for mu to get the SI base units for mu. So there is my mu for which I am calculating the base units. Kg still remains kg, doesn't change. Then meters is still meters, no changes. Then seconds to the negative 2 divided by seconds to the power of 1, I now have seconds to the negative 3. Then also I'm dividing by the amp in the denominator. That will come into the numerator and becomes amp to the negative 1 using laws of indices. Meters per second would then become equal to, now it's time to substitute the necessary SI base units of mu that would make sure that this equation is going to be homogeneous. So if we take a look, we have a kg on the right hand side and we don't have that kg on the left hand side. So that means we need to introduce kgs to the power of negative 1 so that it cancels out the unwanted base unit. We have meters on the right hand side We also have meters on the left-hand side. So this one is okay. We are not going to touch it. Then we have s to the negative 3 on the right-hand side compared to s to the negative 1 on the left-hand side. By which value of s should we multiply so that we end up with s to the negative 1? We should multiply by s to the power of 2. Remember laws of indices, s to the power of 2 multiplied by s to the negative 3, we end up with s to the negative 1. So the SI unit I need to introduce for mu should have s to the power of 2. Then what else do we have? There is a to the negative 1 on the right-hand side, and we don't have that. We need to get rid of a to the negative 1. So that means I would have to introduce a to the power of 1, so that if it multiplies with a to the negative 1, we have a to the 0, and it's cancelled out. So therefore, the base units that I need for mu are kg to the negative 1, s seconds to the power of 2, and we have the amp.